Hello. Today we are graphing linear equations. And if you remember, linear means line. So the first thing we have here, x is greater than 1. Now we're used to graphing this on a number line where I would put an open circle at 1 and I would want to shade all the x's bigger than that. So I would shade off to the right. And that's what this would look like. But if I were to take that number line and build it a second axis, like what you see right below, so like here's my x-axis, here's my y-axis, and try to graph it on that instead. Well, here's where x is 1, and here's another place where x is 1, and here's another place where x is 1, and I want all the x's bigger than that, so this is the direction I would shade, and I could keep going forever and ever that way. Well, when I have a bunch of points like this, I can use a line to represent all of those points. See how they make a linear formation because it's just straight up and down. And I use a dashed line because of the fact that we are just greater than, not greater than or equal to. So dashed line when symbol is not equal to. Okay, and now all of these are going to point this way, every single one of them. So to shade or to color in all where the x's are 1, that would be everything to the right of this dashed line. And that's what this looks like. That's what the symbol or all the solutions for this problem look like. And you can pick any point within the shaded region and you'll find that the x value is indeed greater than 1. How about right here? That's at 1, 2, 3, 4, 5, 6, 3. 6, 3. Is x greater than 1? Sure is. How about down here? That's 5, negative 5. Is x greater than 1? Sure is. Every single spot over here, x is going to be bigger than 1. And again, it's dashed because it cannot be equal to 1, simply just bigger. So let's try this one now. I have y greater than 3x minus 4. So we're used to graphing the line y equals 3x minus 4. And the same principle is applied here. We have a y-intercept. My y-intercept is negative 4. And my slope is 3. So I'll start at negative 4 on the coordinate plane and do a slope of up 3 and over 1. So up 3 over 1. And I can do that a whole bunch. I can also go down 3 and left 1. And again, because we're greater than and not simply greater than or equal to, it requires me to do a dashed line through these points. But these are not the solution because it's dashed, it's not equal to this, and thus all the points on here are not actually solutions to this problem. So we need to figure out which way to shade. And we want y's that are greater than 3x minus 4. So if you consider this 3x minus 4, that red dashed line, we want y's bigger than that. Well, my y-axis goes up and down. This is the y-axis and this is the x. So if I want y's bigger than that line, well, which direction do I have to head to get y's that are bigger? And it would be up. So because we are greater than, this should work. So again, I'm going to shade now everything above this line. And there we go. And again, I can pick any point I want, plug it in, and I should get a valid solution. So how about a nice easy one? How about 0, 0? If I do 0 greater than 3 times 0 minus 4, well, that means 0 is greater than 0 minus 4, or that 0 is greater than negative 4. And that certainly checks out. So 0, 0 is valid, and it shows that we are shaded in the correct direction. And we are done.